So, uh, hello everyone. In my last meetup, I had discussed about the problem of reverse the array, and again, as usual, we have come up with this the reverse array, the same problem, but with with some next solution. In here, there we were trying, we were using the technique of recursion. We were understanding that how the recursion works basically, and we were doing those problems with by making the recursion tree, and just we just want to reverse the array in a recursive manner. Today we are doing the same question, but we are just changing our approach. Also, if you want to see that question, how we have used the recursion problem, or if you have any doubt that how did we solve that recursion question, you can please come up with the comment section and comment to us that how it worked, and if you want any personal assistance with me, also you're most welcome. Okay, so if you see, there might be some doubts you might be facing, or you people might be facing. So, due to which uh, you people can ask to us. Okay, so 1 minute. Okay, let me share my screen, and yes, and I will recommend you that so you can also solve this question anywhere. You can, but here I'm recommending you to just solve the same question with while using your this Naukri 360, that is by Coding Ninjas. This is also a decent platform. So and that is totally up to you where you want to solve. Okay, I'm just doing this just to make some interesting, and so that is the reason. So okay, so let us start with the problem. So usually what we do, we just first understand the question, then we solve the problem. Okay, we understand the question, what is the question is saying, and usually we solve the problem. Today, as you people know that what is the question is all about, and what is saying, and it is visible also into the screens. So I just want to say, I just want to first I will explaining with this cases only. And Also just one thing more, that I will be just using the second solution. So first let's check up the code. So okay, so most important recursion interview questions, because it teaches how recursion works without creating extra arrays. Okay, so because you see the question looks very easy, it's very easy. How you just we just have to reverse an array, but it teaches us that without creating any extra arrays, how can we? Because see, it is these are mostly in place operations and in place questions that we're doing. What are in place question and in place operations? We'll be understanding in the later videos. Okay, so let us start with our solution. So what could be the other solution? Okay, actually, this solution reverses an array using recursion. It's instead of creating a new array. See, first understand what I want to say. Instead of creating a new array, let me open my whiteboard, and it would help you. First, I want to write the code, but slightly directly jumping up to the code won't work. If anyone and any yes, you're just studying with anyone, so I should just check the font size also. That how is it visible to to you or not? Okay, I think now it is quite visible. Okay, so the solution reverses an array using recursion. Instead of creating a new array, we use two pointers, one starting from the left and one starting from the right. Okay, at every recursive call, we swap these two elements and move both pointers toward the center. Once the pointer meet or cross each other, the array is completely reversed. So while saying by see, this you can you are able to understand that which solution I'm talking about. Although I will be discussing it just afterwards, but what I'm talking about and what could be the other solution for the same question. Okay, okay. I'm not writing the whole. Uh, See, these I'm just making you these notes for you. If you want the notes, you can please comment it down and I will provide you. But I'm not directly providing the notes, so you please better to just pause the video and just make the notes with me. Okay. It's of no use of just watching the video. So it's totally up to you, but I will recommend this thing to make notes with me. So I'm just creating the small notes, not the whole from start screen to bottom, but like what the when you're revising, you just also have to revise in a manner that you can speak up to the interviewer, because mostly in interviews these kind of questions can be asked. They are very high probability, not in not very high level interviews, but in a medium average interviews also they ask this question, and they want you to just what kind of approach you are using. For example, reversing array, we can use there are many inbuilt operations that we use, and we can reverse in it. It's not a big task, because the question is it's very simple, but it is how we deliver the solution, and how we approach give better approaches. That is the most prominent thing over here. So we use the two pointers. Okay, with the 2 pointers. So basically we are just using these uh, 2 pointers. Okay, 2 pointers approach. So we just want to use these 2 pointers approach over here. Okay, so one starting from the left and one from the right. Okay, at every recursive call, we swap these two elements. Okay, swap the two elements. So at every recursive call, we swap these two elements. As I told you that when we are doing the recursion, when a function is calling the last one, it is this want to swap. First, it is swapping, and then it is joining both the elements. For example, it's 1 2. So first of all, it is calling left, then recursively calling right, then calling left. For example, when you are calling a right, that means the last part of the array, first part of an array, and merging both the things. So that was a recursive call. But in pointers, what could be the approach? What could be our approach? Once, this once a pointer meet or cross each other, the array is completely reversed. Yes. So the introduction immediately tells the interviewer. This is the you can see. Okay. So since I know about recursion, since I know about recursion, okay, since I know about recursion, okay, since I know about recursion, so interview immediately tells the introduction. It will tell that in the interviewer that this much of answer. This is the answer we have to deliver to the interviewer. So this much of part will immediately point to him that I know about recursion, I know about the 2 pointer technique, and I know about the stopping conditions. Basically, these are the three prominent things that we should know. What is the first one? Is the recursion. Second one is the 2 pointer, the 2 pointer technique, and third is the stopping condition. Okay, third one is the stopping condition. Okay, third one is a stopping condition. So for step one, function, what is the function definition? Okay, step one is the step for now we are moving to towards the step one as we did yesterday. Okay, first is the step function definition. So at step one, see where we were defining I was defining the function over there. See function, you have to define the recursion array. That is that I'm not gonna write over here. So recursion array. So what the variables you can take? You can take uh, the array to reverse the index starting from the beginning and the index starting from the end. So the okay. So the array to reverse. Then what I can take? It's very simple. It's 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 the index starting from the beginning. And what is the index starting from the beginning? You can easily point out. Index starting is starting from the beginning. Okay, then then index starting from the end. Index starting from the end. So okay, so for now, see now, please please focus on this part. I just want you to just see it once, and just if you're not getting something, you should watch twice. But this is very simple. So if you're watching it once, you can also get up the answer. So if I could take this sample out, okay. First of all, we're not increasing the complexity of the problem. We just want to explain the question with another other 2, 3, 4. Same array 2, 3, 4, 5, 6. Okay, this is our array. This is our array. Not something nice. What is left and what is right? So what I had to take left and right. Yesterday also when I was explaining you the recursion problem, in recursion also we were taking a left and a right. So what is that left and what is that right? There are also left and right. So left is 0 and right is 4. So left is a 0 and right is 4. Since the indexing starts from 0 to 0, so that is the reason we took it 0, and you can count also 0, 1, 2, 3, 4. Okay. Initially 0, right 0. So and now since now at the step 2, okay, this make this point this not see this data was this is a step. This whole part is it's a part of the step 1. Now stores step 1 somewhere. See, this is the pseudo code, as I'm always saying you, that is a pseudo code. So this is a step 1 of a pseudo code. So you just point your pseudocode at one place and just think about the next step. Okay, you what you did, you just take an array. You just want to index an array, you give up the 2 indexes from the beginning, from the end. You define the indexes also, from which index you wanna start. Okay, now the step 2 comes in the picture. Now the step 2 comes up in the picture. So at the step 2, we want one stopping condition. Okay, let us understand what is a stopping condition. We want one stopping condition. Now you can ask to us that why. Why is it? See, now you should ask the question that why should you want a stopping condition? See, when left is equals to right. Okay. It's a but left is equals to right. So both pointers are on the same element. For example, this is your left, this is your left, and this is your right. Okay, this is your right. Okay, this is 1 minute. This is your right. Okay, so this is your left and this is your right. So when if this say if this missile or this left pointer missile is moving from this side, this right one is moving from this side, there will be the one condition at any cost. It is possible that if they are moving consistently and they would be getting meet up. For example, I'm talking about a crossing condition that every recursive call of the 2 elements, once a pointer meets across each other, the array is completely reversed. So here we're not talking about a crossing each other, we are talking about when array meet each other. Pointers meet each other. So for example, they're meeting up at from for 4 or 3. So that means left is right. It can be like three, three three or 4 or 5 or 6 or whatsoever. Okay. So both pointers are on the same element. So I should define it like the both pointers are on the same element. Okay. Okay. Both pointers are on the same element. So now let me take one example also. That 1, 2, 3, 4, 5, 6. Okay, let's 5. Let's talk about 5. Okay. So if 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 this, for example, left comma right, both are pointing to or pointing to 3. Okay. For example, this is the same. Left pointer, my left pointer is also at 3, and my right pointer is also at 3. That means they are pointing to the same indexes. This means okay. So nothing is left to swap. For example, so what do we get? That nothing to left to swap, and that's a very good point. So the pointers have okay. So now there would be one more condition. This what when left is greater than right, that pointers have crossed. This would indicate pointers have crossed. Example 1, 2, 3, 4, 5, 6. Okay, let's keep it to the 5. So that means uh, right and right and left has been have crossed each other. So we can, so at this point we say that at this point the swap required at every step, swap required has been cleared. Okay. Swap required has been cleared. Okay. Without this condition, function would keep calling itself forever, causing a recursion error. Maximum recursion depth will getting exceed. So you might get TLE or whatsoever. So TLE is the one. So if we are not pointing this condition, so recursion error with maximum, for example, maximum depth will get exceeded. Okay. So now moving towards the step 3. Okay. So basically, if we are not implementing these conditions, the use of these conditions are that you have to point out these conditions. Otherwise, you will get the TLE call or the time limit exceeded and runtime errors. So for preventing all those things, we just provide these conditions, and it is I think the point of clarity has already been there, but because it's not a very complex thing to understand, that for example we have left and we have right pointers, we have 2 pointers, and 2 pointers if we're pointing to the same conditions, that means the pointers are on the same elements. That means nothing swap, and if they have crossed, the array is already been requested. Okay. So now okay. Oh, okay, 1 minute. Yes. Now this is the step 3. Step 3 of swap. Step 3 of swap. So in the step 3 of in the step 3 of swap, 1 minute, I would recommend here we will get we just have to swap as usual. As usual, swapping will be there. For example, array okay, ARR array of left comma right will be right array of, see, normal swapping, this you might be understanding what I'm see already know what is this array of right comma left. Okay, array of right comma left. So Python swaps both element in one line. In one line, Python Python swap. So this is the benefits of Python that many people use Java. I'm not against of any language. It's totally up to you. But Python has this leniency or this benefit, or whatever you can say, that it is easy to implement. Okay. So now just try running the code. If you start, if you want to understand the code procession, what does the code wants to say? To swap. So suppose array is equals to 1 comma 2 comma 3 comma 4 comma 5 is left is equals to 0 and right is equals to 4. Okay, so before swap, uh, okay, left is equals to 0 and left is equals to 0 and right is equals to 4. Okay, see, 1 minute, remove this element 6. So that means there are 5 elements, and left is here, and left is 1 and right is 5. Okay, left is 0 and so what would we get after doing this? So left is 0 and right is 0. So before swap, this left, see, since we haven't swapped till now. Okay, so what our array would say that here we have left, okay, comma 2 comma 3 comma 4 comma 5, and here we have right. Okay, here we have right. Okay, so this means it is a condition of before swapping. Let me point it out over here. It's a condition of before swapping. Okay, now we just want to, after swapping, what would we get after swapping? 5 comma 4 comma 3 comma 2 comma 1, and okay, 5 comma 4 comma 3 comma 2 comma 1, and then the first and last element is exchanged. Okay, first and last elements are exchanged. First and last elements are swap. Okay, first and after swap, see, step 4 is the, and now we are moving towards step, that is a recursive call. Okay, so, for example, now we have the recursive call. How? See, again, the recursion has been implemented, that and reversing an array comma left plus 1 and right minus 1. So now we move both pointers, okay, like this, and that would point as left plus 1 and right minus 1. Move right pointer backward. Move right pointer backward. Okay. Okay. So if you're moving a right pointer backward, so what would happen? See, it will see, first of like, see, just understand this thing. So this is the crucial part. It's 5 comma 4 comma 3 comma 2 comma 1 comma 1. So it's here. So first of all, first and last element gets swapped. Okay, so we have our array like this. Okay, but uh, in the recursive call, so first our left is pointing to this 5, and because a right minus 1, see, right is already there here. Okay, right is already here. So right, if we pointing to the last index, but so it should be moving forward by doing plus 1. But if you're doing minus 1, so right would lost its right would be getting lost, will lost its path. So right will come here. So after when we do it again, we are doing left plus 1. So after, what will be there? 5 comma 2. So okay, 5 comma 2, and here our left pointer would be, okay, here our left pointer would be 3 comma 4 comma 1, and uh, right is already here, and right is already here. So now, so this is the concept of recursion. So as usual, recursion continues. So in the two-pointer approach also, we can see the concept of recursion as usual. Okay, we have seen the concept of recursion. Okay, so that is my aim. So again, if we have someone has problem to understand the question, so I can do this also in a glance, because we are in a shortage of time. I think okay. Meeting time is see, in 10 minutes I will be wrapping up all the things. Okay, see, complete dry run of the code. It's the initial array. Okay, initial array. So the initial array is 1, 2, 3, 4, 5. Okay, so call one. Call one says left is your 0 and right is equal to 4. Then swap, then swap. Then we have to swap. So one. Okay, so one will get see. Call one left is see. I'm starting from the very first part. Uh, that left is 0 and right is 4. Again, pointers are at first and the last steps. Okay, no problem. So one would get swapped with 5. That's a very simple thing to understand. Obviously, one will get swapped with the 5. So what is the problem? So what will be an array? 5 comma 5 comma 2 comma 3 comma 4 comma 1. Okay. So one, because one is getting short to 5. So here you would see that recursive call, that is left, that left is equal to 1 and right is equals to 3. Okay. Now call 2. This was call 1. Okay. Again, when was the call to and again swap. What will be swap? Uh, Swap 2 with 4. Okay. Sorry. Swap 2 with 4. 5. So that swapping 2 with 4. So that would give us 5 comma 4 comma 3. Yes, comma 2 comma 1. Okay. Now again recursive call. Okay. Now again recursive call where left is equals to 2 and right is equals to 2. So here the point, uh, so it denotes the pointers are meeting towards both the point. And see, here as you can see, to call first of all, so it's not minus 1 first of all, it's is equals to. So call first it was on like left was on first on 1 and the right was on 3. Okay, and they're merely talking about the indexes, not about the elements as well. So now we did perform the call, and now move call 3. So left is equals to right. As I told, the pointers either meeting to each other or the pointers are crossing each other. We met with a situation where the pointers are meeting each other. So that means the base case becomes true. Okay. So as I said, that we have to implement a condition that we have to implement a condition as likewise. See, we have to implement a condition to avoid the for time limit exceeded, because recursion will call itself and going inside the depth, and that will be the never ending loop and you will get a time limit exceeded. So for preventing that thing, we are justifying our base case. Since the base case becomes true, and we will return a array as usual, with no ifs and no buts. So what will be the final output that people can guess? That is 5 comma 4 comma 3 comma 2 comma 1. See, one thing more. This array is too simple to take this array. This is a little bit complex. not too much. See, reversing is never a complex thing, but for practicing, you can take the test cases of for these of these this question. But this test case was very simple. So so after two maximum three calls were required, and after three calls, they already swapped the array and reversed the array. Okay, so by this we will use the recursive call stack. uh, we will get the recursive call stack. So first of all, we should first write the our um, the question first. Mm, this is the code editor. First, we should write the question first. Okay. Uh, See, basically, this is the this see format. Okay. You have to start writing the code from here. So if um, mm, first you have to define if your left and your right pointers as usual over here. And I think if I want, see, we are running shortage of time, so I should just make you the code over here. Okay, 1 minute. Okay. Now it is going on. Okay. So uh, if left, see, first of all, left is equals to if left is equals to right, and return array. Okay, and also array of left and array of right. Okay, then is equals to array of right. Okay, uh, comma array of left. Okay, so by doing this, we can get the solution. You can make it like that in reverse underscore array arr comma left plus left plus 1 comma right minus 1. Okay, left plus 1 comma right minus 1. And here you can just we have written this thing, and see, I am just changing the whole code here. Merely it won't this code won't get work, and because this code won't be running in your like answer. But what you people have to do, you have to write this whole code with yourself, and then paste it in the comment section, because I'm just giving the idea of the code, not providing the whole code, because then it will be of no use. I just want you people to understand the concept, not the code. So okay, so this as you people can write this code with the help of with with your approaches and your ideas. Okay, so I'm just providing you the idea that how you have to write the code and how the code structure can be.